All right. I'll take this opportunity and to discuss question number 6 on your chapter 4 homework. Okay. Um, this is a fairly complicated question. All right. And I strongly encourage you to try this and to get started, and then try it one more time, and then you can maybe watch the video and get some help. All right. So this company is considering investing in a new machine for one of the factories. Okay. The company has two alternatives to choose from. Right. The lifespan of each machine is 5 years. Okay. The company sells each unit for a price of $6, and the company has a cost of capital 12%, tax rate 35%. All right. If the company manufactures 1 million units per year, what machine should it buy? Okay. And we have the parameters here. So you have the machine A, machine B. All right. And so let me just put this down here. All right. I have machine A, machine B, and then we have the annual fixed cost. We have the variable cost. And we have the annual production from each machine. All right, so I'm just going to save some time. So let me just copy and paste what I had earlier from my essentially from my solution here. Okay, all right. So that is the information about these two machines. Okay, and if the production is annual production is, let's say, 1 million units. All right. That's the case, which machine should this company buy? Okay, so you're really talking about the NPV of these two machines. So, I mean, you can still go about the incremental project of going from, let's say, one machine to another. Okay, but I'm just going to actually look at these two machines here. All right, so I'm going to look at, machine A. All right, and down here, I'm going to look at machine B. Okay, and if I need to actually produce 1 million units, machine A is only going to produce this amount here, so I can look at number of machines if I go with A or B. Right, so I take this and I divide this by the annual production from each machine, and I get 2.5. So really you should actually make it 3 here. Right, so you can actually do the round off function here, and I'll just do the round off, and I have 0 decimal, and that should actually cost me 3 machines, because 2 machines is not enough. Right? If you do 2 machines, you're just going to have 800,000. Okay, so you're short of 200,000 units. All right, and I'm going to look at this one here, and if you're going to produce 1 million units, each one is good for 500 550,000 units, so you should actually have 1.18. And again, you can't have this amount of machines, so you should do round off here again, right? So I'm going to use this round off function here, and you need to have 2 machines for machine B. Okay, all right. So let's look at the timeline here. All right, the lifespan is 5 years, so that's easy. All right, so let's build a 5-period timeline here. Okay, and it's the same timeline for machine B, so I don't mind copying, paste. All right, so let's look at the cash flow per period. Okay, if you're going to go with machine A, well, how much you're going to spend? Well, each machine is going to cost this amount. Okay, and you're going to have 3 machines here. All right, and so that is your total investment if you go with machine A. Okay. All right, so let's look at your cash flows per period. Okay, so if you're going to produce this amount, okay, and if you're going to produce this amount, you can sell it for $6 per unit. So that's going to be your revenue, right? And then you're going to actually pay a lot of a cost here, and some of the cost is actually variable cost, so that's 1.2. Okay. And that's per unit, and you're producing this amount of unit, right? And some others are fixed cost, so that's the fixed cost for each machine, and you actually have 3 machines. Okay, so that is your revenue minus the cost. So and now you can actually start paying tax. All right, tax rate is 35%. Okay, and if that's the case, then you're going to ignore the depreciation, so we just need to put back the tax benefit of depreciation, right? So the tax benefit of depreciation is the tax rate, which is 35% times the annual depreciation, right? So I have this amount here, and I need to actually make it positive. So I flip the sign here, or I can use the absolute function here, right? So this takes the absolute value of a number, right? So that is the total cost, and you're going to depreciate this over 5 years, okay? So that's going to be your annual depreciation, right? So if you do that, you get, hang on, I think numbers are actually a little, all right? That is how you calculate the after-tax cash flow if you go with machine A. All right, I think there was earlier there was a mistake for the annual fixed cost per machine. That should be 300,000. I think I put down 30,000 initially. All right, so this actually is fixed. All right, so that is the cost. That's the after-tax cash flow for year 1. All right, and now I need to actually copy this across. So I need to lock down essentially everything here. All right. Okay, so if that's the case, I can copy this across. All right, so I get the after-tax cash flows for the other years. And now I can go ahead and calculate the NPV. All right, so the rate is the discount rate. That's going to be 12%. Okay, and I'm looking at the future cash flows and putting back the initial investment. So that is the NPV if you go with machine A. All right, so I'm going to format this. Okay, that is $66,119. All right, and now let's look at the machine B here. So cash flow per period. If you're doing machine B, let's look at what's going to happen here. First of all, how much you're going to spend on the machines. Each one is going to cost you this amount, and you need to have 2 of them. All right, so that is your total cost. Okay, and let's look at the after-tax cash flow if you go with machine B. First of all, they're producing this amount of unit. Okay, and you're actually selling it for $6. Okay, and you need to take out the variable cost, which is actually 80 cents per unit. Okay, and you're actually producing 1 million, 1 million unit. All right, and then you need to take out the fixed cost. So this is the fixed cost per machine, and you actually need to have 2 of them. Okay, so that's going to be your revenue minus the cost, and now I pay tax 35%, and now I just need to think about the tax benefit of depreciation. 35% times the annual depreciation. All right, so the annual depreciation is going to be the total cost. Okay, and I need to lock these down, and this is actually depreciated over 5 years. So this amount here is the annual depreciation. All right, so if I do that, I get this number here, and I can copy this across. I get all the other numbers. Whoops, I think I made a mistake. There's a number here I need to lock down. B11. B11 is the number of units. Okay, all right, so I need to lock these down here, and I should copy this across. Okay, all right, so now we can actually get the NPV for the machine B. All right. So the discount rate is still 12%, and I'm taking all these future cash flows, and putting back the initial investment. All right, so this number again is $1. Okay, so this is telling you if you're just going to produce 1 million units, A is the choice because NPV for A is positive, NPV for B is negative. All right, so now you're actually trying to produce a graph to show the profitability of the investment in each machine type depending on the annual production. Okay, so I'm going to look at building the data table for NPVs, okay, based on number of, or based on the annual production. All right, so I'm going to actually build a data table in a row. All right, so let's see whether we can actually get this done. All right, so I'm going to look at the annual production here. So you want to actually look at a possible range of the annual production. So I'm going to do, how about 200,000. All right, so, and then I'm going to increase by 100,000 each time. Okay, so I'm looking at 200,000, 300,000, and so on and so forth. Okay, all right, I can make this even longer. That's not a problem. Okay, so these are the hypothetical ranges for the annual production. Okay, so I'm going to look at the NPV for A, and that's the calculation here. And I'm going to look at NPV for B, and that's the calculation here. So let's see whether we can actually get this done. Okay, so I'm going to highlight everything, and I'm going to go with data, what if, data table, and my row input cell is the number of units or the annual production. That's the number I use when I build my NPV calculation. Okay, so I just populate everything, and you see that when you're producing 200,000 units, neither A nor B would be preferred. But you see the NPVs are actually flipping to let's see, this is a negative, this is positive, okay, and this becomes negative again. So you see that it's actually fluctuating, right? And if you want to plot them, it's not a problem either. So let me just highlight all the data you want to use for your plot, and let's enter the chart, okay? And I'm going to do, how about a line chart? All right, so that will be NPV based on, or I should say NPVs based on unit production. Okay, all right, so that will be the line chart title, and I have two series here. So this one is the machine A, and this one is the machine B. So I can actually manipulate this data here, this chart here for a little bit. All right, so this one is NPV for, NPV for A. Okay, the second series is the NPV for B. All right, so that should do it. All right, I hope this is useful. I'll stop the video here.